This video is going to cover automotive engineering, how to get into the field, and a few examples of what's going on in the field. But first, let's define some things. Automotive engineering is about the design, manufacturing, and operation of cars, motorcycles, trucks, and other automobiles. There are a lot of subdisciplines within automotive engineering, and there are many things you can work on when it comes to an automobile. For example, you could work on the safety aspect in assessing various crash scenarios, whether it be on the computer to doing actual crash testing. Cars need to meet certain standards to protect the driver and passengers. The frame of the car would have to be designed properly such that energy from a crash is absorbed or moved away from the driver. Like I said in a previous video, cars are meant to crumple in an accident as engineers design them like that to save lives of the people inside. If the car was extremely strong and no damage was done to it, all that energy would be transferred to the people inside. There's performance in analyzing how fast the car can accelerate, how quickly it can come to a complete stop, which of course is important, and more. There's vehicle dynamics and looking at things like braking, handling, and steering and how the vehicle will respond. The engineer who works on this would have to analyze or design the braking, the tires and wheels, suspension, they could work on the frame as well, and more. There's the fuel economy where you look at fuel efficiency in miles per gallon and test car emissions such as hydrocarbons, carbon monoxide, carbon dioxide, and so on. But of course this wouldn't be the case for electric vehicles. There's the shift quality where you focus more on the transmission, the durability of the car, electronics, and much more. Overall, just note that there are many components to a vehicle. Common jobs would be like designing on the computer, testing, and actually working with a physical vehicle, or even manufacturing where you help with the making of the vehicle and its components. Now when it comes to college, automotive engineering is rarely offered as a major, at least for undergrad. The most common major to go into is mechanical engineering, and then you would pursue careers in the automotive industry, or you'd get your master's and even PhD in automotive engineering. But that's not the only option if you want to work on cars. I said before that materials engineers can work on cars, electrical engineers can work on cars, especially with electric cars becoming a thing. Computer scientists are even needed for self-driving cars to write the programs for the autopilot as an example. And there's even mechatronics, which may be its own major depending on your school, or it's just a subfield of mechanical engineering, but this can lead you to working on the car control systems and similar aspects. And these are just to name a few. So you can work on cars through various majors, but mechanical is just the most common one people think of, and it also depends on which aspect of the vehicle you want to work on. Now a huge area of research you probably all know of is self-driving cars. Companies like Tesla, Uber, Google, Toyota, Ford, General Motors, and more are all aiming to get self-driving cars out on the road. Now we do have self-driving cars right now, but there are restrictions to them, and at the moment we are still waiting for a fully autonomous vehicle that's available to consumers. But Elon Musk says that we should have a self-driving car that can go from LA to New York completely on its own in the near future. Though there are plenty of obstacles that exist, like being able to sense unexpected encounters like an officer directing traffic or a broken stoplight. They need to deal with ethical decisions and what to do in a life and death situation, operating safely in various weather conditions, and so on. So lots of engineers would be needed for this. Because self-driving cars have many components to them as well. Just to name a few, there's the LiDAR, or light detection and ranging, which basically uses light to detect surroundings and is what you see on the top of the Google car here as an example. There's the GPS, which the car uses to navigate to its destination and so that it knows where you are. There's the radar system, which is also used to map out the surroundings, but using lower frequency waves than light, or what the LiDAR uses. And this has its advantages. As one example, LiDAR will not work with heavy fog, whereas radar will. And then there's cameras, which read the road and the surroundings as well, but they can also read traffic lights. And research is going into putting these together with even more components to make a safe self-driving car. But even though self-driving cars seem to be the main thing happening, other aspects of cars are also trying to be optimized. Take the new Audi 8 suspension. This new suspension system incorporates an electric motor for each individual wheel. There's a camera on the front that reads the road and detects bumps so that the air suspension can coincide with those bumps, and with those precise reactions, you can nearly eliminate vibrations. Working with the camera and transmission of data could be worked on by an electrical or maybe computer engineer, but the suspension system itself and doing tests on vibration would be something a mechanical engineer would do. There's research going on materials that aim to make lighter but safer cars, and this may involve looking at different types of metals that have different properties like varying strength and density. A lot of the metals in cars today did not exist just 15 years ago, and we are still continuing to make advancements in this area. Now, just to show again how much there is to work on, I found a Forbes article that I linked below that's titled, "What Will Mechanical Engineers Do After Most Cars Go Electric?" Which is a fair question because electric cars don't have an internal combustion engine, and so are the mechanical engineers needed? Well, of course they are. Even though mechanical engineers do work on engines, most of them work on other stuff. Think about what a car really has. The airbag, the trunk mechanism, the suspension, shock absorbers, the frame of the car, the windshield, and even the windshield wipers. Everything that a car has, someone, and usually multiple people, have to work on, design, test, and manufacture. The article even really shows you the detail when they say how even the plastic taillight cover had to be made accurately and economically so that it could fit the car. And another engineer even had to design the machine that makes that taillight. There's so much more detail than you may think about all the things that we use. So yes, mechanical engineers are of course still needed. Now when it comes to companies you want to work at, you may think of some of the typical ones like Honda, Toyota, Ford, Tesla, and so on. But there are also suppliers for these companies, and I saw multiple articles state that you might even do more of the cool design work at those places that you probably haven't heard of. For example, take Honda as an example. Huge company that I'm sure everyone watching knows of. But do you think every single part of a Honda is made by them at their plants? Because they actually are not. Many other companies help with certain parts, and I'm sure most people haven't heard of the majority of these companies. According to Investopedia, AGC Automotive supplies Honda's windshields, Takata supplies their airbags, Borg-Warner supplies the automatic transmission systems, Automatic Spring Products supplies the seat components, and there are more. So even if you don't land the job at Honda or Toyota, just realize how many more companies there are that you can work at. Now something like windshields may not sound very exciting, but if you go to the AGC Automotive's website, which I said is the company that supplies their windshields, and look at their products, you'll see a lot of things. Things like heads-up displays on windshields, which basically display dashboard information on the windshield so drivers can stay focused on the road. There's high insulating glass for heat transfer optimization to maximize comfort. They're trying to make lighter windshields to help improve the car's MPG by reducing weight. And they're even working on glass where with the press of a button, you can control how much light and heat comes in, which helps reduce the need for AC. So when people say they want to work on cars, just realize there's way more to it than you may think. You may help design the overall concept of a new vehicle, but you might help design the windshield, the suspension, the frame of the car, and various other specific aspects of these vehicles. In college, you want to make sure you also get involved in automotive projects. Look into joining the Society of Automotive Engineers, or SAE, which your school might offer. Then you'll be updated on competitions you can participate in. Look up the Formula SAE, which is a student competition amongst college students where they aim to design a formula-style race car like the one you see here based on certain rules, such as which engine you might have to use. Then you're scored by a variety of factors like cost of manufacturing, acceleration, fuel economy, endurance, etc. There's also an electric vehicle competition done by this organization. You'll work with a team, get hands-on experience, and you have a great thing to put on your resume. So I hope this gave you a general summary of what automotive engineering is and what you can expect in the field. If you liked the video, don't forget to comment, like, and subscribe, and I'll see you all next time.